Hi and welcome back. So in this video, what we're going to do, since we've kind of talked a little bit about isotopes, what we're going to do in this video is I'm going to give you a couple of different isotopes, and I'm going to give them to you in I guess we've only covered two of the different notations that we can possibly see isotopes with, or possibly represent isotopes with. And pretty much what I want to know is, what we want to find out is the number of protons, the number of neutrons, and the number of electrons. So actually, let me write that down. So we want the number of neutrons, we want the number of protons, and then we also want the number of electrons. So let's start with an example. And, you know, as always, this kind of goes for all of these examples. Probably the best thing to do is wait until I state the problem, pause the video, try to work it out on your own, and then unpause it and see if we both got the same answer. So this first example, we're going to be looking at radon, which is down here on the periodic table. Its atomic number is 86, so we're going to have radon 86. And the isotope we are going to be looking at, the mass is going to be 222. So now, how many protons does this have? And that should be a pretty easy question. We're going to have 86 protons, right? Because that's the atomic number. That's what defines that we're looking at an atom of radon, is that we're looking at an atom with 86 protons. In all of these examples, we're going to say that these isotopes are going to be neutral atoms. So because it's neutral, how many electrons is this atom going to have? Well, it's going to have the same number of electrons as it does protons, right? Because proton will have a positive 1 charge and electron will have a negative 1 charge. So we're going to have 86 electrons. And now for the number of neutrons. So how do we figure out how many neutrons we have? Well, we know that this number, our mass number, is going to be the number of protons plus the number of neutrons. So we can just write out a little bit of algebra. I'll just give myself a little bit more space. We can write down that the number of neutrons, so where else actually, you know what, I'll just say that our overall mass, so our overall mass, or our atomic mass, our overall mass number, is going to be equal to the number of neutrons plus the number of protons. So we know the number of neutrons. We know we know the number of protons, rather. We've got 86 protons. And we know the overall mass number. We know that the overall mass of this isotope is radon 222. So now all we have to do is just solve for n, solve for the number of neutrons. So what are we going to start off doing? Well, we subtract 86 from both sides, right? So now what is 222 minus 86? Well, if we say that that's 222 minus 80, so that would be 242 minus 6, which would be it should be 132 minus 6, so that would be 136, I think. So the number of neutrons, and so all I was doing was I was subtracting 222 minus 86 is going to be equal to the number of neutrons. And so I guess we can plug this into a calculator. I'm pretty sure that this is going to give us 136 neutrons. Let me just double check that, because I don't want to give you wrong arithmetic. So let me figure out 222 minus 86. Yep, 136. So we are going to have 136 neutrons in this isotope. Let's do another one of these. We've got enough time, so I'm going to clear all that off. Let's say I gave you the isotope, what's a good one? Let's say I gave you phosphorus. Let's say phosphorus is going to be right here on the periodic table. its atomic number is 15, so we are going to have phosphorus. Atomic number is 15. And let's say we are dealing with phosphorus 33. So now how many protons does this have? Well, it's got that's our atomic number is 15, so we've got 15 protons, but you're probably getting the hang of that. How about how many electrons does it have? And remember, this is a neutral atom, so all of our protons are going to be balanced out by the same number of electrons, so we're going to have 15 electrons. And so now how many neutrons will we have? Well, it's going to be the number of neutrons plus the number of protons is going to be 33, right? So we're going to subtract 15 from 33. And so what would that be? 15 minus 33. That's 18. 18, right? So we would have 18 neutrons in this isotope. So anyway, hopefully you're getting the hang of this. Maybe, you know what, I'll do one more of these, and I'll do it with the different notation. Let's say, what's another good one? Let's say we had nitrogen. We were looking at nitrogen, which is right here on our periodic table. Its atomic number is 7. So let's say we had nitrogen 14. And this is the symbol that we got. So if you remember from the other video, we could also represent, you know, our isotope just by writing the name out and then dash and then the mass number. Because to say the name of the element and also give the atomic number, it's kind of redundant. If we know what the name of the element, we also can figure out what the atomic number is. If we know what the atomic number is, we can figure out the name. So anyway, we're looking at nitrogen, and the mass of our isotope of nitrogen is going to be 14 AMU. So now, how many protons? How many protons do we have? Well, our atomic number is 7, so we've got 7 protons. And it's a neutral atom, so we need just as many electrons. So we are going to have also, let me change colors. We are also going to have 7 electrons, right? And then finally, how many neutrons? Well, the number of neutrons is going to be our entire mass number, so 14 minus the number of protons. And we've got 7 protons, so that means that we're also going to have 7 neutrons. Hopefully you're getting the hang of this. Anyway, I guess that's good enough for an example. An example right now. Hopefully, this is making sense to you. We might do a few more examples, but in the future, I'll start introducing you to some new concepts, which maybe we can make the examples a bit more interesting in the future. So anyway, thanks so much for watching, and I'll see you in a future video.